Bismillah ar-Rahman ar-Rahim. Uh, in this lecture, we will discuss about lecture 8 of Ethical Hacking and Network Defense course. The topic is understanding and attempting buffer overflow. So in this lecture, we'll talk about many points, starting with introducing buffer overflow. We will understand what buffer flow exactly means, and then we discussed two memory architectures that are susceptible to buffer overflow, which are stack and heap, and then we will cover about methods to mitigate or to prevent buffer overflows. Okay, so let's start with introducing buffer overflow. What does it mean? It says here a buffer overflow occurs, it happens when a software program or process attempts means tries to write more data to a fixed length block of memory or buffer than the buffer is allocated to hold. What does this mean? Imagine you have two bottles of water. One of them is 200 milliliter and the other one is 500 ml. So the small one is 200 ml and the big one is 500 ml. And you wanted to pour the water from the small bottle to the bigger bottle. What happens? What will happen in this case? Firstly, the small bottle will be filled with water. Okay? And then خلاص, it's full, it's already full. So what happened to the rest of the water? It will overflow, it will go outside the bottle. And this exactly what happens here. For example, I have 2 megabytes of buffer to store some data. Okay? But the program or the process doesn't only use 2 megabytes. It will use, for example, 10 megabytes, or it wants to write 10 megabytes inside memory space which only can hold 2 megabytes. So what will happen first? First, it will write in the 2 megabytes, and then the rest of the data will be written in other memory space. Okay, and this is when buffer overflow happen. Okay, we are trying to use more data than the allocated size. Okay, why this might happen? Why buffer overflow might happen? Because programmers, when they program, they don't check the bound of the data we are trying to enter. It means I don't check the size of the data that I want to enter. Okay, so maybe the data I want to enter is exceeding the memory limit, the size, the space I'm given. So it happens because of the lack of bound checking. So what's a buffer? We talk about buffer overflow now. What's a buffer? Buffer is memory location, memory space, memory location. In a running program, we use that memory location to store things on a running program. Used for storing temporary data. We use it for limited time data, not for forever. Okay, so we use it to store data temporarily. And being okay, so memory location, buffer is a memory location in a running program that's used for storing temporary data. طبعا temporary doesn't mean that it's for short time. No, it might exist for longer time, but at the end it's temporary, it's not forever. Okay, now we talk about some memory architectures in which the buffer overflow happen, which are stack and heap. So the two common types of buffers used in computing are stack and heap. We have two types of buffers, stack and heap. Both memory architecture can be used for buffer overflow. Stack both overflow are more common than heap overflow. We have stack, we have heap. Both, okay, can be can are susceptible to buffer overflow, but stack overflow is more common as compared to heap overflow. Okay, so now what's a stack? Stacks are contiguous areas of memory. What is contiguous? 1, 2, 3, 4. These are contiguous, one after another, close to each other. So stacks are contiguous areas of memory that are dynamically allocated at runtime to store variables. So it's an area of memory we dynamically allocate it. It doesn't mean that before I start the program I allocate the memory or I specify the memory I will use. No, we allocate it during the runtime and we use it to store variables. It's like a memory space that is dynamically allocated to store some variables, some data. طبعا it's dynamic as we said, so it can grow and it can be smaller, shrink. It can grow and shrink. Grow means we push data, we add data, okay? And when you remove data, it's called what? Pop. So when you add data, it means it's pushing. When you remove data from the stack, it means popping. So push and pop. You add data. So the stack grows and shrink as you add and remove data from the stack in a fashion. What's the fashion? Last in, first out. So the last item you put in the stack is the first item to go out of the stack. Last in, first out. The last item you put on the stack, it means it's the first item to remove from the stack. Memory address go down as you add data to the stack. Now we are talking about specific details, which is the memory address. How it goes? Here I give you an example. If the memory address ends in 0x8, this is the last one, the last memory address for the last data you put before the data is added to the stack. The memory address may be 0x4. Therefore, when the item is pushed to the stack, the processor decrements the register, moving it to a lower memory address. So it goes down. It was 0x4, 8. After, for the next data, it will be 0x4. So it decrements 0x8, it become 0x4. The memory address go down as you add data to the stack. As so. So it started 0xf and then it gets reduced to 0x4. This is the way. طبعا you add buffer variables to the buffer or to this stack. This is the bottom of the stack and this is the top of the stack, and this is the return pointer to tell you where is the exact location or the exact location of the data. Okay, so we know what's heap. Now we talk about we know what's stack. Now we talk about heaps. Some applications require large buffer than the stack provide. So there's a limitation with the stack. It provides only with limited buffer. Okay? But we don't want that. We want, for example, for some data, for some application, we need large buffers. So for that reason, we use heaps. Okay? So heaps are used when large buffers are needed, or when the contained object size is not known. So in two cases we use heaps. The first one, when we need very large, very big buffer. The second one, when we don't know the size, okay? We don't know what's the object size to put. So here we use heaps. Buffer overflow, stack overflow and heap overflow are the same technique and so on. Let's take this example of a code in which buffer overflow happens. So this program, when compiled and run on a host, causes segmentation fault. See, there is another name for buffer overflow is segmentation fault. Okay, so it causes segmentation fault. Segmentation faults occur when a program tries to access memory locations that have not been allocated for the program's use. It means that the program is trying to access some data that shouldn't be accessed. Okay, so let's see this example. Int my array 3. So it means it's giving only 4 spaces, 0, 1, 2, 3. And then we define some variable I, int I. For I less equal 0, I less than or equal 10, I plus plus. See here. I is what? Okay, my array I equal 10. So here, my array, we define it in the beginning to be only 4 memory spaces. And here it's 10 from 0 until 11. So here a buffer overflow happen. I'm specifying small buffer size, but I'm writing big data that exceeds the size of the buffer. So this is the problem here. Okay, what happens after buffer overflows? After the buffer overflow problem happen, what happen? What might cause? It might cause crash the program, so the program will shut down or return bad data. This is not common today because it has been solved. Or it run other programs or commands. It execute other commands, execute other scripts and so on, which is really dangerous. So attackers can put malicious code in the extra buffer and it causes many problems. And it's very hard to detect it. We discussed what's buffer flow, we discussed about stack and heaps, and what are the problems that can be caused by buffer overflow. In this section or in this part of the lecture, we'll discuss about methods how to prevent buffer overflow. So it's the programmer who decide how to solve buffer overflow. The programmer, when they write the program, have to think about methods how to prevent buffer overflows. So prevention of buffer overflow rests with the initial programmer. Use languages that are less vulnerable to buffer overflow like Java, Python, or Perl. Use some languages are more vulnerable to buffer overflow than others. So use Java other than, for example, C or C++ because it's less vulnerable. Okay, in C and C++, use commands that are newer. For example, use str and copy instead of str copy. We will know the difference between them, but this one is newer than this one. So using str and copy is better than using str copy, and we will discuss later why it's better. Okay, because str and copy limit the amount of data to be copied. It means there is a limit, there is bound checking. So you cannot just copy and paste. No, it will check, there is a limit. So str copy function copies the whole content of one string into another string. It take all the string and put it in a new place. This is strcopy. Whereas strncopy copies the data portion by portion, part by part. Okay, it divides the data into portions and it copies it portion by portion, جزء بجزء. If destination string length is less than the source string, entire specified source string value will not be copied into the destination string in both cases. So if the destination is less than the source, it will not be copied as a whole. Okay, that was the first solution. So better to choose the best language and be careful with the commands. So instead of writing a function, instead of using strcpy, use strncpy. So that was the first solution. The second solution is using canary value. Canary value is a method, okay, using some words. If you see these words, then you know there is a buffer overflow happening. So canaries are, or canary word, are known values. They are values I choose that are placed between a buffer and control data on the stack to monitor buffer overflow. So it's like a word or value. If you see it, then you know that this is buffer overflow happening. When the buffer overflows, the first data to be corrupted will usually be the canary. So if the buffer overflow happens, then the canary value will be overflowed. Okay, so I know that it has been overflowed, it has been changed, then I know directly that this is happening. By verifying the canary value, execution of the affected program can be terminated. So the solution, if I see that the canary value has been changed or corrupted, then I quickly terminate the program to prevent it from misbehaving or from allowing the attacker to take control over it. So we stop the problem directly by terminating the program and so on. So that was the second solution, which is using canary value. The third solution here, and which is very easy, is bound checking, checking the bounds, نشيك على الحدود, and tagging. So bound checking, check access to each allocated block of memory, so they cannot go beyond the actual allocated space. It means I check the space and I make sure that I cannot exceed the given space. This is bound checking. The other solution here is tagging. What is tagging? It ensures that memory allocated for storing data cannot contain executable code. I check that the data that they want to enter, okay, the memory allocated for storing data cannot contain executable code. I make sure that they cannot use this allocated memory to put executable code or to put script, because attacker might want to put, for example, a virus or some script. So I prevent it. I just allow them to put data, numbers, letters, so on. They cannot add any executable code. Also, certain areas of memory can be marked as non-allocated, preventing buffer overflows. Okay. Another tool is using some library tools, using some tools that are written or that exist in order to prevent buffer overflow. An example of these libraries is libsafe. So this library, libsafe, help to track stack pointers and assist in preventing stack smashing or stack or buffer overflow by checking the return pointer and preventing them from being overwritten. If they are overwritten, then it will directly terminate, close the program. But there is a problem with libsafe. It degrade the application performance sometimes. Sometimes it make the program, for example, slower, or it degrade it. Okay. There is other solution called compiler-based solution. Compiler-based defense usually aims to prevent or detect buffer overflow. It can prevent or it can detect buffer overflow. And an example here is GCC. GCC give you warning. When you do something wrong, it give you a warning. Like for example, warning gets is deprecated. If you use this function gets, it tell you that it's no longer used. You better change it with something else. So this is compiler-based solutions. The last point we discuss is performance versus security. Here is something very difficult to choose. Can I choose performance or I choose security? Which one is more important? Is it the performance, the speed of the program, the functionalities, or the security is more important? Here is like a trade-off. Which one to choose is very difficult. There are also a lot of good protection techniques. Many of them have the potential to provide full protection. However, they incur too much overhead. They cause too much overhead on the program. Overhead means too much يعني الضغط كبير جدا على البرنامج فبيكون أبطأ البرفورمانس بيكون أضعف and so on. So the trade-off between performance and security is very important system engineering topic. Which one to choose is very difficult. So that was it. And in this lecture we discussed about buffer overflows. We talked about stack and heap, how they work, how we put data, how to push data, how to pop data, and then we talk about how overflows happen, and then some solutions to try to reduce the buffers. So that's it for today. Thank you very much for listening, and inshallah I'll see you next time. If you have any question, please do not hesitate to discuss with your lecturer